Welcome to Mathematics Lecture series. Today our topic is Laplace transform of discontinuous function. Lecture number 4. Find the Laplace transform of a function defined as f of t is equal to t square whenever t is between 0 and 1, and elsewhere f of t is equal to 0. 0 to 1, it is function f of t is equal to t square, and elsewhere this function f of t is 0. In fact, this is discontinuous function, so we discuss the Laplace of this function. Laplace of f of t by the definition of the Laplace transform 0 to infinity e power minus st f of t dt. Here f of t is defined in two ways, so we break this integral according to domain of this given function. 0 to 1 e power minus st t square. So 0 between 0 to 1 this function gives t square, so we have write f of t is equal to t square plus 0 to 1, 1 to infinity. Elsewhere this function is 0, so this integral goes to 0. So we have rest 0 to 1 e power minus st t square dt. Now by using integration by parts, we solve this integral. Laplace of f of t integration by t square is same, taking the integral of this term e power minus st, which becomes e power minus st upon minus s. 0 is lower limit, upper limit is 1, minus here 0 to 1, here t square is same, so taking the derivative of t square 2t according to the rule of the integration by parts, taking the derivative of t square 2t, and write the same integral here e power minus st over minus st. Now if we solve this term, use the upper limit 1 square e power minus s1 over minus s. By using lower limit t is 0, so it whole becomes 0. Just we have minus e power minus s over s. Minus into minus plus 2 s take to the outside the integral, so 2 over s. 0 to 1 t e power minus s t. Again use here integration by parts. So first term we have e power minus s over s, this is resolved, plus 2 by s. Now use here integration by parts. So t is same, taking the integration of this term e power minus st over s, upper limit lower limit, minus 0 to 1, so by the rule of integration by parts, taking the derivative of this t is 1, same integral right here e power minus st dt. So if we apply the upper limit in this term 1, so we have again e power 2 by s e power minus s over minus s, so minus 2 e power minus s, s into s, s square. So minus into minus plus, plus and 2 over s, if you multiply with this s, so 2 over s square 0 to 1 e power minus st. So e power minus s over s minus 2 e power minus s over s square is solved, and 2 by s, taking the integration of this term e power minus st over minus s 1 over 0. If we use the upper limit, you will have e power minus s. If you use the lower limit minus lower limit, you have the just 1 e power s 0, you have just 1, so s square into s cube. So this is our last answer of the given function f of t. Now find the Laplace transform of the function whose graph is, you can see that from 0 to 4 this graph, this function is equal to minus 1, whenever if we consider this value on this horizontal axis t and x-axis is f of t. So if t is less than equal to 4, so this function gives -1. If t is greater than 4, so this function is equal to 1. Find the Laplace transform of this f of t. Laplace of f of t by the definition of the Laplace transform 0 to infinity e power minus st f of t dt. This is represent f of s. Laplace of f of t 0 to infinity e power minus st f of dt. So 0 to infinity, this range break into t less than equal to 0 to 4, 4 to infinity. E power minus stf of t dt, e power minus stf of t. Between whenever t is less than equal to 4 means f of t gives -1. So we write f of t replace with -1. Whenever t greater than 4, this function gives 1. Now taking the integration of this integral minus e power minus st upon minus s 0 to 4 plus 4 to infinity e power minus st dt. Minus into minus plus 1 over s. So apply the upper limit e power minus 4s minus e power 0 lower limit. Solve this integral and proper integral e power minus st minus p 0 p to infinity. So 1 over s e power minus 4s e power 0 is equal to 1 plus limit p to infinity. Apply the upper limit e power minus ps minus s minus into minus plus lower limit e power minus 4s upon s. 1 over s e power minus 4s minus 1 e power minus ps over minus s. P tends to infinity, so this term goes to 0. E power minus infinity 1 over e power infinity 1 over infinity 1 over infinity is equal to 0, and we have just e power minus 4s upon s. So we combine these terms, we have e power minus 4s upon minus 1 over s plus e power minus 4s upon s. So these e power minus 4s upon a 2 times, so 2 times e power plus 1 over s. Here s must be not equal to 0 and greater than 0. This is our last answer of a given function f of t, which is discontinuous function. Thanks, and we complete this on lecture on with these two examples. Kindly subscribe, like and share this video as you find more videos on the Laplace transform and other topics. Thank you.